Let's identify the first table. We are going to see if it's linear, exponential, quadratic, or other. We're going to go ahead and check to see if it's exponential, and to do that, we're going to check for our ratio. So to find our ratio, we're going to take the last output divided by the previous. So we're going to take 51.84 divided by 86.4, and that gives us 0.6. Then we continue the process. 86.4 divided by 144, that gave us 0.6. So we had a good hunch. This looks like it is an exponential table because it has a common ratio of 6. Okay, so this is an exponential function, and because it has a common ratio, okay, that is 6. Now we need to write an explicit form. Well, an explicit form for an exponential has the form f of x is equal to a times b to the x. And remember, a is our y-intercept. Do we have our y-intercept? We do not have our y-intercept. To find our y-intercept, we need to find what is our output when our input is 0. So here, notice if we go down the table, we will multiply by 0.6. So that means if we're going to go upward, we're going to divide by 0.6. So we're going to take 240 divided by 0.6, and that's going to give us 400. Okay, so excuse my chicken scratch. So we have 400 times b is our common ratio, 0.6 raised to the x. Okay, and that is our exponential form. Finally, we need to write recursive. So recursive, remember, is always going to have this form right here. We can start at 400 as our output, or we can start at 240. So we're going to start 400 if our input is 400, 0, okay? And then we're going to take our previous output, multiply by 0.6 if x is greater than 0. And there we go. Okay, for the second one, we're going to try to find the common ratio. Okay, so that means I'm going to take 47 divided by 60. That gives us 0.788. We're going to repeat 60 divided by 73. That gives us 0.821. We do not see a pattern when we find the common ratio. So that means we're going to resort to finding the first difference. So to find the first difference, we're going to take 47 minus 60. That gives us negative 13. Then we take 60 minus 73, that's also going to give us negative 16, and so forth. Okay, so this is a linear because the first difference is constant and it is equal to negative 3. Now we need to write the explicit form for our linear function. And to do that, I'm going to change my pen here. F of x is equal to our y-intercept. Yes, it is here. We don't need to find it. It's delta x plus 73. Okay, so negative 13x. Let me rewrite this a little bit better. Okay, sorry about that. So it's going to be negative 13x, okay, plus 73. Okay, finally we need to write the recursive form. I'm out of room, so I'm going to erase, okay, this work down here. Okay, so let's write recursive. So f of x is equal to, again, you can start any initial output, but I'm going to go ahead and use 73. My output is 73 if my input is 0, and then we're going to subtract 13, okay, to get us the next. So there you go.